Good morning or afternoon, ladies and gentlemen, boys, girls, fellow Homo sapiens. Welcome to the wonderful world of today. Okay, I've been asked to do some sample problems, so here's an example problem that hopefully will help you with Problem E worksheet. A clerk moves a box of cans down an aisle by pulling the strap attached to the box. The clerk pulls with a force of 185 newtons and an angle of 25 degrees with the horizontal. The box has a mass of 35 kilograms. And the coefficient of kinetic friction between the box and the floor is 0.450. Find the acceleration of the box. All right. We, of course, like to start with what we know. And this time, what we know. We know gravity, 9.81 meters per second squared. Hopefully, you're starting to memorize that. The mass in this problem was 35 kilograms, 3 sig figs. Force due to tension was 185 newtons, 4 sig figs. Angle, 25 degrees. Coefficient of kinetic friction. I draw the free body diagram. The free body diagram is simply a box in this case. It's actually what it is. And we draw everything from the middle. That's where we say all the forces are acting. We call that the center of mass, hopefully. So we have the normal force pushing up. We have the force due to gravity pulling down. We have the force due to tension from the strap that the person is pulling. Notice I've added that towards the center here. And then we have the force of kinetic friction, which is in the opposite direction of motion. Now, the one force that is not along the axis, or any of the axes, is the force due to tension. That is the one we're going to have to break down into its components to put everything along the axis. That's how we've been adding, when we can, our vectors. Okay, we do the Pythagorean form of addition, which means everything needs to be along the vectors, the axes. So we know the force due to tension in the x direction is simply the force due to tension cosine of the angle, and the force due to tension in the y direction is simply the force due to tension times the sine of the angle. Okay, notice in this case, the normal force is actually less than the force due to gravity. Oh wait, that can never happen. Yes it can. Remember, the normal force is smart. It knows it only has to supply enough force to support the object. Well, if we have another force pulling it up, this is less. If not, we would see an acceleration coming out of the chair if you were sitting in one, or off the floor, or something along those lines. No, this always just balances. So we're going to probably have to find that, and that's where I'm going to start, because I know I'm going to need to find the acceleration in the x direction, which tells me I need to find the force of kinetic friction. I already have the force of tension in the x direction, but I need to find the force of friction. Well, my frictional force, my force due to kinetic friction, is going to be mu sub k times F sub n. So I already know I need to find the normal force. So that's where I'm going to start. I'm going to start with the forces in the y direction. Okay, my forces in the y direction. The sum of the forces in the y direction is equal to the mass times the acceleration in the y direction, which in this case is 0. The mass is not 0, so it must be the acceleration that is 0. This must equal, well, we have the normal force plus the force due to tension in the y direction minus the force due to gravity. That tells me, I'm trying to find the normal force here, the normal force then must equal, well, I have to subtract this to get it to the other side. I have to add this. So minus F sub t y plus F sub g. And remember, if I do it on one side of the equation, I have to do it to the other. That means I'm subtracting the same thing here, minus F sub t y plus F sub g, which means I get F sub g minus F sub t in the y direction. That is going to be my normal force. Well, pretty simple. We know the normal force, the force due to gravity, is simply mass times the acceleration due to gravity. That's mg. Minus my force due to tension in the y direction, that is then sine of that angle. So our normal force here must simply equal m, which is 35.0, times 9.81, minus the force due to tension, which is 185.0 sine of 25.0. You could certainly probably use the practice of actually calculating this yourself, so it'd be a great time to pause and see if you get the same numbers I do. And if we do this, and assuming I put my stuff in my calculator correctly, I get 343.35 minus 78.1, lost the number, 843,7842. Now I'm assuming you guys have the cool calculator that'll let you just move these numbers around so you don't have to retype them. Again, this should have 3 sig figs. It should be good to the ones place. This should have only 3 sig figs, so it's good to the tenths place. If I am subtracting, I'm going to round to the least precise place, which would be to the ones place here. Although I'm not asked for the normal force, so I'm just going to write down my number, which is 265.165.6216, I hope, unless I wrote something down. Again, that should be only good to 3 sig figs. If I'm reporting the normal force, it would be 265 newtons. Okay, we're partway done with the problem. Yay! So, what we need to do now is look at the x direction. Well, the sum of the forces in the x direction must equal the mass times the acceleration in the x direction. Which Newton's law is that? Hopefully the second, F equals ma. That must equal all the forces that are acting in my x direction. Well, we have a component of the tension force acting in the direction, and we have the force of kinetic friction. That must equal force of tension in the x direction minus the force of kinetic friction. The force of kinetic friction can never, ever be bigger than this force. Frictional forces are smart as well. They can't exceed the other forces. You can't have friction making stuff move in the wrong direction. Be kind of interesting if we could. Doesn't work that way. So, this is what we are trying to find. We're trying to find the acceleration in the x direction. So, we have the mass times the acceleration in the x direction must equal the force due to tension in the x. Well, that's just the force of tension that was given to us. X direction, that's the cosine of the angle in this case, minus mu sub k F sub n. Okay, this is why we had to find the normal force before. Well, that means my a sub x, which is what I am trying to find, must simply be equal to the force of tension, cosine of the theta, minus mu sub k F sub n, all over m. Should equal 185.0 cosine of 25.0. Again, remember, if this has 3 significant figures to start with, running the function should still give it 3 significant figures. Minus 0.450 times the normal force, which is 265 and some change. Ran out of room there, but you have the number from over here. All divided by 35.0. Again, this would be a great place to stop. See if you can calculate this yourself. Okay, I've given you all the numbers. It's now just up to you and your calculator. So pause and try. See if you can figure this out. Okay? Hopefully you've paused and tried to figure this out. For this number, I get 167.6669 and some change, minus 119.3245297. Wow, apparently I wrote the whole thing down there. Again, this should only be good if I were giving the number for sig figs. 4 and 3 should leave me in the ones place. 3 and 3 should give me, in this case, to the ones place. Here's the trick. My answer's only good to the ones place on top. Okay? So 3 sig figs, ones place, possibly on top, divided by 35.0, which is 3 sig figs on the bottom. Okay, for me, that number goes 1.381211. That only has 2 sig figs. Why? Let's take a step back. If I do this top number minus this number gives me 48.342,41088, I hope. Wrote all the numbers, maybe not, over 35.0. Remember, these two numbers up here were only good to the ones place, which means this number's only good to the ones place, which means it only has 2 sig figs. Again, the whole reason we worry about sig figs is how far we can trust our answer. Okay, it deals with how far we measured. And we get this. My final answer then should be 1.381211-ish meters per second squared. Rounded to only 2 sig figs, we get 1.4 meters per second squared forward. Okay, it's an acceleration, most likely has to have a direction with it. Okay, hopefully you found that helpful. And remember, ladies and gentlemen, boys, girls, drive fast, take chances, do inappropriate things with people your own age, and above all right now, kind of counterintuitive, but stay safe. Miss ya.